Okay, thanks so much. Thanks for letting me be a part of this today. I'm going to talk about some data security practices with your Lakehouse architecture and with Databricks, of course. So a little bit about me to start off with. My name's Chris Williams. I'm a senior consultant of data engineering at a company called Advancing Analytics, and we primarily do a lot of sort of Databricks, like Lakehouse, sort of data platform builds for clients, essentially. And I live in York. I moved here about 11 years ago, and essentially a friend of mine lived here. I came to visit one weekend and thought, wow, this place is lovely. So I've been here ever since. If you want to know a little bit more about me or the kind of work that I do, I blog at headinthecloud.blog. And I'm available occasionally. I tweet on Twitter, and that's at chriswilliams87. So to start off with, I'm going to talk about the data lakehouse, and we'll do a little bit of a sort of catch up about, so we're all on the same page. What is it? Well, for many years, data teams have been consolidating and storing all of their business data in a structure like that of a data warehouse, really. That's a classic monolithic application to bring together all of the separate systems that exist in the running of the business. And this can then be accessible, an accessible location for cleaned and enriched data, aiding the business in decision-making and business intelligence. We know that as the quantity and the variety of data increased, there emerged a demand for a more flexible structure, really. A way in which we can curate not just our typical structured data sets, but also semi-structured like JSON, or even unstructured forms, perhaps like audio or the sentiment from documents. The data lake emerged to accommodate this. However, without proper organization and governance, the lakes often descended into this sort of stereotype of the data swamp, where business trust in the data becomes very low as the quality is reduced. So a couple of years ago, the design for the data lakehouse emerged as a solution to bring together the cost-effective storage flexibility of these data lakes, but with the integrity and the management features of a data warehouse. So here, as you can see on my slide, this is sort of the high-level components of the data lakehouse in Databricks. We have the data lake foundation at the bottom. It's unrestricted in the formats that it can accommodate. And at the top, we have the key features that Databricks provides to us. So that's that of advanced data engineering with Apache Spark, the ability to work with both batch and streaming operations, and an extensive machine learning library, which is MLlib. One of the key parts of this is essentially the middle section, the Delta Lake. This open source storage layer that provides ACID transactions, schema enforcement, and the ability to roll back to previous versions of the execution history. That's just to name a few. So I suppose under the hood, then, how does that work really? And what does an augmented data lake look like, and sort of how is it structured? Well, this is known as the multi-hop or the medallion architecture, depending on where you're reading it. And this is a collection of 3 or more overarching containers where the quality and business usefulness of the data is then improved at each stage. So to start off with, we have that of the bronze layer, or the raw layer, as we call it internally. And as stated, this maintains the original raw state of the data as it comes in, as it's ingested. It is appended with each increment and then grows over time. As the data is in a state in which it comes, sometimes there might be some erroneous parts or rows in which we'd like to remove or amend with some data cleaning operations. And so the question that probably comes to mind is, why would we preserve even rows that are not really desired? Well, preserving the history in a raw state allows for a place to repopulate the lake from without having to return to the demands of a source system. So that's one of the benefits. Then next we have the next layer, which is that of the silver or the base layer. And this is your validated single source of the truth, really. Transformation and data quality rules have been applied at this stage, and that provides the business with a trusted and enriched data repository. And then finally, we have that of the gold or the curated layer. The gold of the curated layer, this drives analytics or machine learning. Data is refined into aggregations or data models to add business-specific context to your data sets. So this could be for subject-orientated collections of tables, or perhaps a reporting model to provide insights then further to the wider business. Okay, so we've got our curated lakehouse, and we're containing some of the data sets in the different parts of the lake. So I suppose now what? How do we get those data sets then in the hands of the people that need them? How do users access parts of the lakehouse? And at which point are users granted access? You know, how do we do that in a safe and secure way? And do we allow everyone access to raw, base, and curated containers? You know, bronze, silver, gold. You know, do people require that? Who needs that? Well, if we look at a typical sort of set of personas within the business, we've got that of the business users. So they need access to just the curated data for reports, don't they? Is that true? You know, if perhaps in the business, if there's more self-service analytics, perhaps they are going to do that from base and they're going to do their own modeling. What about that of the data engineer? Where do they access? Do they need complete oversight of every part of the lakehouse to develop those ETL jobs? Or maybe in the business, there's some citizen data engineers and they just perform the modeling around the created layer. And also we'll be looking at that of the data owner or the data steward. You know, they need full knowledge of the data within a domain. So, you know, where do they fit in this? Do they need the full end-to-end access, or do they need perhaps just at the end? These are some of the questions we essentially need to consider. And how can we do this in a way that follows a sort of least privilege approach? So yeah, we're going to look at what are the challenges and who are the people that are involved then to make these kind of decisions or have these discussions. So I've tried to conceptualize this into the perspectives of sort of three personas really that would be in the business, and who are going to raise these kind of questions, and who might need to be reassured as they go through this sort of development process. The first one might be that of a representative from the security team or an overarching infrastructure team. You know, this will be somebody who is responsible for cloud infrastructure overall in your Azure tenant maybe. You know, they might have questions of how are the storage containers secured? What are the credentials that are being used, and how are they being used throughout the platform? We'll look at that from a perspective of a data engineer. You know, they're designing, as I mentioned, most of the ETL pipelines. They might have some questions about how will data then get in the hands of the consumers that need it. And then finally, we're going to look about some solutions or some questions that might be raised from a data steward or that of the owner. As I mentioned, they have oversight over data within a domain, so they might be quite concerned about how, you know, so who is accessing these kind of data sets. So to start off with, let's look at the platform, how to secure that, or how that is secured, I should say. Okay, firstly, if we look at the architecture from a very high level, Databricks is a PaaS, a platform as a service, and the backend services are managed by Azure Databricks. This obviously, if you were to read, this allows data teams to stay focused on data engineering, data science and analytics. But what is actually managed by Databricks? Well, essentially the architecture is divided into these two planes, that of the control plane and the data plane. The control plane, this plane is managed by the Databricks instance and handles your workspace and cluster configurations. So once you spin up a cluster, then the configuration of that and the schematics of that cluster is obviously handled by the Databricks instance. Sign-on is authenticated by Azure Active Directory. However, the credentials are not sent directly to Databricks. Looking at the other plane, the data plane, this is within your Azure subscription, or the client's Azure subscription, and this is where your data resides. This is where it's transformed and where it's processed. Configurations in the control plane are encrypted at rest, and there's encryption applied in transit for all communication between the control plane and the data plane. So if you've, as I mentioned, if you're running jobs or you're launching clusters, or you've got some metadata that comes from the feedback of those data sets, then that's all encrypted as it moves between those layers. Some of the architectures will vary, as you can imagine, based on any kind of custom network configuration, but this diagram essentially represents sort of a typical structure, really. So let's look at a user access case. That's obviously in Azure is managed by Azure Active Directory. This uses role-based access control, and as users are granted the privileges that come with a defined role, and then that's accepted to a particular Azure resource. In order to manage users of similar personas, it's recommended to use AD groups to provision these users together. But we don't, however, want to manage a separate catalog of user access within specifically the Databricks environments. So this is a way in which we can synchronize users and groups from Active Directory into Databricks using what's called the SCIM, the System for Cross-Domain Identity Management application. That's what's represented here. Once we've created this application, we can provision selected AD user groups or users, and at certain time intervals, we can automatically synchronize that with our chosen Databricks workspaces. Keeping the management of Databricks groups consistent then across all of our cloud environments. So let's look at secret scopes. Let's look at credentials, really. Often in our processes, we need to use credentials to authenticate an external data source or request maybe from an API, for example. And using notebooks within Databricks is great for code collaboration or exploratory data analysis. That makes it very, very accessible. But we don't want to have these credentials available within the code for just anyone to see, anyone who has access. And this is where secret scopes come in. And this is a way in which we can protect these keys or secrets from any unauthorized access. In order to keep these, to keep all of our credentials in a secure location, we can also register an existing Azure Key Vault to retrieve these secrets from. From the Create Secret Scope menu, we can define a scope name and register the DNS name and the resource ID of the Key Vault to have that available for use within Databricks. Then using a simple DB utilities command like secrets.get, for example, we can retrieve any secrets from that vault, and they will be redacted then if you're attempting to preview them within the code or within the notebook. So looking at the storage, every Databricks workspace is provisioned with a distributed file system known as the Databricks file system, or the DBFS. Databricks uses DBFS root directory as a default location for data assets without an explicit storage location defined. So if you were to create a new, say, set of Delta tables in your metastore without explicitly specifying a location for the storage within your tenant, it will default to this DBFS. And a significant issue with that is that DBFS is accessible to all users granted access to a Databricks workspace. Therefore, all users can essentially access any data stored within it. So we have to be mindful of that. It's encouraged to specify an external storage to contain the data sets and as a location when registering those to those kind of data frames, for example, to the Hive metastore. Previously, we would have mounted an external ADLS Azure Data Lake storage account using a service principal to authenticate and display the mounted location as if it was part of the Databricks file system. However, that is actually recently changed. as of September, so very recent, is now recommended to register the service principal as the usual kind of roles, which are like storage blob data reader or storage blob data contributor if you want read and write access, and then register this within the data access configuration settings within Databricks Sql. And that's a new development, really. And this particular method, it's not included in this particular talk due to it being so recent, but I will cover some aspects of Databricks Sql in the next section. And I'd recommend everyone who mounts in the manner that I've already expressed, that maybe just consult the Databricks documentation for further information on that. So I'm going to do a bit of a quick demo. I've had to sort of reprioritize my demo slightly because a lot of my colleagues have been presenting at various things, so there is a lot of demand for clusters at the moment. So just to make sure that things work okay, correctly, this is more of a curated demo. So we're going to look at, sorry, just go back. We're going to look at how we would do the Active Directory synchronization using Skim that I mentioned before, and also how would we enable some secret scopes. So to start off with, we'll go to the Azure portal, and this is my resource group, my sandbox resource group that I've been doing a lot of the demos with, and as you can see, I've got some of the resources there for creating this sort of lakehouse. To start provisioning a Skim application, we're going to go to Active Directory from the toolbar on the left. And there we're going to click on from Enterprise Applications, we're going to select a new application. Yes, from there, we're going to choose a Azure Databricks Skim provisioning connector, which will pop up if you search from the gallery there. Once that has been created, once it's been provisioned, we've got our application there, and then we need to try and initiate the provisioning. So you can select that from the provisioning on the toolbar on the left, but before that, we need a little bit of information from our particular Databricks workspace. So we'll go over to that, the one that we've created, and we're going to go to the user settings section. And from here, we're going to create a PAT, a personal access token, so that our Azure tenant is able to connect and communicate with our Databricks workspace. So we're going to create a token there. I've just called AD Skim integration, and we'll give that a duration for that particular token. When that pops up, we will have, as you can see there, we'll have it will be showed just briefly where you can copy that token. That's obviously the only time that you can see that at that stage. So it's recommended that you store it in a secure location from there. Then going back to the Skim application, we're going to paste in our tenant URL that we've got from our Databricks workspace, and we're going to include /API 2.0. It's a preview feature currently, and then /Skim, as you will see there. And then we're just going to paste the secret token that we've just obtained in the previous screen. And then when we test that, we can see that that's working effectively and it's communicating there. So for the purposes of this example, I'm just going to add one of my personal accounts just to this so we can provision that to the workspace. I know I mentioned earlier, obviously we'll probably want to do this on a group basis, but for the purposes of this, I'm just going to do it on the user. So I've selected myself there, I've added that. And then I'm going to go to provisioning. I'm going to select start provisioning. And as you can see, we've got one user that has been transferred to the workspace. And if I go back over to the Databricks workspace, you can see there that I have my account that I used to create the actual workspace resource, and then my personal account that I already discussed, and how that has been then pushed to my workspace. So looking at secrets, I'm going to access the Key Vault resource that I created as part of that resource group. And we're going to need a little bit of information for this in order to transfer that to Databricks. So if we go to the properties section on the left-hand side toolbar, we need the vault URI, and we'll need the resource group to copy this. Then from there, we can go to back to our workspace, our Databricks workspace, and we'll need, you can get this this link from the documentation, or you can simply go to your workspace URL, and then you can do hash secrets and / secret scope, and you'll get this menu here where you can create a new secret scope that is backed by a key vault, a particular key vault. So here I'm going to call it Sandbox Secrets, and I'm going to paste in that DNS name and that resource ID that I just mentioned. And now in this notebook that I've got here, once that's been secured, I've just got a couple of examples of functions that you might want to run just to check that that's working effectively. So I've got the secrets.list scopes, so I can see any secret scopes that are available within that particular Databricks workspace. And I've got secrets list for that secret scope. So here you can see the all of the secrets that are then being pulled through from the key vault. And finally, at the bottom one, I am doing a secrets.get that I mentioned in one of my slides. I am trying to query the tenant ID secret that I've got in that key vault. And as you can see, it's redacted there. So it will be protected from anyone developing on that particular notebook. So now moving over to maybe the data engineer perspective, we're looking at ways in which we can secure the data itself. So once we have our data lakehouse built, we've populated it, we've got some ETL pipelines that's populating the data sets, it's ingesting and transforming our data. We face some access and security challenges there. We can't simply just let users, just any users, sort of dive in and access whatever they want in the lake. Ideally, we want a way to sort of restrict some access to these certain entities or collections and allow sort of the serving of selected data to these users. And this is essentially where Databricks Sql comes in. Databricks Sql is a data warehouse layer on top of your Lakehouse, essentially. And this lets you run SQL BI applications at scale. It also has fine-grained governance and access control with the ability to create sort of dashboards for your reporting if that's what you require. Here I'll demonstrate sort of a few little examples of how we can utilize the features of Databricks Sql to provide a querying environment for your data engineer or your citizen data engineers or analysts. But also carefully manage the access and restrictions needed to create a secure environment. So how does Databricks Sql manage access to these databases or these tables? Here is an example of a sort of typical data lakehouse from the perspective of the storage account. Here you can see the folders and the containers for each of the section of the multi-hop architecture and the data sets within them. We, however, don't want to provision access to this hierarchy exactly. We want to create some views or some Databricks database entities to serve the data effectively. So tables, views, and databases can be registered in the Hive metastore in order to create these objects, and it can be served via the endpoints of the Databricks known as the Databricks Sql warehouses. This is another name of the clusters that are ideally used for just the servings rather than the data engineering practices. In this example, we have sort of a situation where some reporting analysts can be given access to a curated set, while a data scientist perhaps they may be conducting some exploratory data analysis, so they might need require access to actually just the base entities as they come. So sort of how can this be done? Well, on an individual basis, you can use the Data Explorer UI, and there is a permission section within that where we can add the groups and those ones that I mentioned that are synchronized from Active Directory. Or we can do this a bit more programmatically, and we can do this in SQL by using a grant statement, which you can see just at the bottom of my slide there. Using a grant statement such as this, this allows for a reporting group, as I called it, to just have select access to a curated data set, although permissions for greater control are also available. If there is ever a requirement to view access granted to a database or to a table or a view, that can be achieved by using simply a show grant statement. So looking at a bit more fine-grained, I guess, let's look at an example of how we can achieve some row-level security then through Databricks Sql. So in this particular example that I've come up with, the scenario is that users, we want them to select from a table. However, we want certain rows to be restricted based on the particular group that a user is in. This could be maybe some business units that are specific, or if we are serving this out to clients, they may be in this particular example in a certain region, and therefore we want row-level security to apply to that. So yes, as you can see here, I've got a data set that has country codes across the UK and France, and there is a number of sales in that. So to achieve this, we can do this with some dynamic views over the top. So we can create a group based on the particular country code for this, for France, for example, FR. And here, as you can see in the statement on the right, I'm creating a view country sales, and that is going to be selecting from the fact table that this is representing. And using this function isMember, this will check simply if the user is the member of that particular group, and it will filter using the where clause. It will filter that view just so they can see at the bottom those rows that are associated with the France, with the FR country code. So that's a sort of easy example of how we can do some row-level security on those views. For something that might be a slightly different scenario, we'll look at maybe some column level securities, and we've got an example there how we could do that. So for this scenario, a user can select from a table or a view, but we want to maintain the number of rows this time. However, we'll just want to redact some of these rows based on the particular group again. Yes, I've created a view in this statement here. This is country sales, and we've simply, using the isMember function again, I've got a case statement now where it's basically going to check if that exists, and if not, it's going to redact the number of sales column for that particular person. And as you can see in the example below, I've got number of sales, and for everything that is not the in the France group, you can see it's redacted. Okay, moving on for another example that might be useful is that of data masking. There is a sensitive field which we don't want to completely clear, but we want to have it so a view can partially maybe disguise it. We can mask that to be used throughout the platform, really. So how could we do that? Well, we can use a custom SQL function. This is, of course, I've just done this as a SQL example, but if you are using Python, PySpark, this is obviously very flexible. You can do it that way too. This example I'm doing, I'm creating a function which is going to mask, as you can see, I've got some example credit card numbers. So we want to, obviously we want to mask some of those aspects there. So we've got a function that is going to take the last 4 digits of that credit card number, and then it's going to mask it with some hashes, and we can apply that to one of the columns in that view that I've got down there, create view accounts, and I'm applying that data masking function to that column. And as you can see in that bottom example, that's how that's going to appear. And the last little sort of data encryption example I'm going to apply is that if we've got a case where we've got some PII fields, and not just from a serving point of view, but we also want this to be encrypted throughout the platform, so that if anyone is to access the data sets from any stage, and we can do that also here. Databricks comes with a default encryption library, which is the Aes Encryption. And here in this particular slide, I've created a encrypt column function, and also then a decrypt column, which uses an encryption key to be able to apply that to a column. This table in this slide here is obviously not as you would use it, but just to represent how it starts with the city, and then I'm applying the encryption function to the second column, as you can see there, encrypted city, and then I'm decrypting it with the same encryption key, and that then encryption key could be stored in your key vault, for example, or it could be generated for specific entities. I also mentioned, and this is something that I've done with a client particularly, is I wanted to expand the encryption beyond just the default libraries, and using the Fernet library is a good example of how you could expand that further. So for this little demo, I'm going to just show you a little bit of sort of how you would apply that, the steps to apply that row level security, and also some data masking. So we'll go back over to the Databricks, go to the workspace there, and we are flipping over this time, going over to Databricks Sql, which you can see from. This is obviously for premium capacity workspaces. So if you're wondering why that hasn't appeared for you yet, we need to be using a premium workspace. And I'm just going to select that Databricks Sql there. As you can see from this slide, I've got a base and I've got a raw database collection, which has the entities at the different stages of the multi-hop architecture. Just going to have a quick look in this example, just a quick examination of what the data sets, what it might look like. Here I've got the customers table, and as in the similar slide, I'm going to do this based on the state field, the state column. So yeah, so we're going to look at that. Now going back to the data engineering part of Databricks, I'm going to have some control over, I'm just going to add a group. As I mentioned, this is based on state, so I'm creating an Arizona group, just AZ, which is there just for the purposes of this. And then we'll go back, we'll create our curated set of entities, which is our curated database. And I can do that there just with the create database statement. Then if we want to grant access to the group that we've just created, we can do that with, as I mentioned, with a grant select and usage statement. So we can grant that to that particular database. Then in this next one, I'm going to actually create the dynamic view, which is going to do that check to see if that user exists within that group. So here it's going to check, as I mentioned, this is member from there. And also I'm going to apply a similar approach that onto a view over the actual fact table, which in this case is view sales orders. And I'm going to make sure that there is a check so that the customer ID exists in the previous one where it's being executed. And then if I do just a quick select statement on that, I'm going to view the view customers. And as you can see now, only the rows that correspond to the Arizona state, they're the only ones that are appearing. So we know that that is working successfully. And just for a little check, I'm going to do a count from our base table, the sales order fact table, and comparing that to the view that we've created for the sales order view. And as you can see, the base view is the full 4,074 rows, but we're just getting those 90 Arizona specific rows in this next example. So that's worked successfully. And now from a data masking point of view, I'm going to create a function to be able to do that, similar to as I did on my other slide, as you can see here. And there I'm just going to take the first character of the address field, and I'm going to mask everything that falls outside of that state that I'm assigned to that group. So we're going to do that here, rather than with row level security, rather than restricting all of the rows. And I'm going to alter the view there rather than create a new one. I'm just going to do it so now they will be able to see all of those rows. And then I'm changing that now with the alter view statement, and I'm going to do when a case is not member, it's going to then apply the masking. And just as a check, I've done a select just on that view. And as you can see from the rows here, they're allowed to see the city that the customer is based in if they have assignment to that Arizona group, and if not, then it's simply masked out. So okay, from a sort of data owner point of view, this is where I'm going to talk about ways, sort of considerations for securing the catalog itself. So I need to start, before I can go any further, with obviously talking about data governance. We've seen in the previous section some of the different ways in which the data sets themselves can be secured to prevent users gaining unlawful access to the components that they shouldn't. So this may address some of the security concerns on an individual level, but for high-level stakeholders, we require a clear and comprehensive oversight over all the data in our estate to ensure that there is secure management throughout and the data is of high value to the business. So this is where good data governance comes in. This is as a little data governance catch-up. This is a sort of a collection of processes, policies, roles and standards to ensure your data is of good availability, usability, integrity and security. So availability, meaning that are the correct data sets available to the business personas that require them. Usability, are the data sets rich in business context, and are they functionally useful for deriving insights? Integrity, is the data of good quality and is it trusted in the business? And then in security, are correct regulations applied to that data? Is access restricted to only the personas that require it? And are PII, personal identifiable data fields, are they protected where applicable? So what are some of the features that Databricks provides to achieve the governance in the Lakehouse? Well, okay, we only need we need robust security from a platform level and from a data level, as I mentioned, but also through this effective governance and auditing. So a number of these features are available with the Unity catalog. And this is Databricks offerings, Databricks tooling for sort of how is data being accessed and who by, how can we monitor the lineage of the data as it moves through the Lakehouse. And this is something that that Unity catalog provides. It's Databricks' unified governance solution for all assets across all of the Databricks environments that you might have in your organization. So not just one workspace, but all of your workspaces. So access management is one of these features already discussed, but next I'm just going to look at, I'm not going to delve too in depth with Unity Catalog. I obviously suggest that you go away and consider that in the future, but I'd like to look at a couple of features that we know to not just monitor sort of who is accessing the data, but what is being accessed as well. The reporting on those data sets as they move through the stages of the Lakehouse and how they're transformed, but also, yes, as I mentioned, also what is being accessed. So what we can do is we can apply some extensive audit logging. This is something that is commonplace across all of sort of Azure resources, really. And that is from the diagnostic settings that's available for each resource. For the Databricks specific ones, we can enable logging for the clusters, for the secrets, which secrets are being accessed, for the particular jobs that have been run, and any notebooks sort of that are being executed, really. This can then all be sent to log analytics, and this can be combined with all of your existing service logs that you might be getting from your other resources. One thing to note about Databricks, though specifically, is that it has a verbose logging feature, which you can turn on in the admin console in your Databricks workspace. And this is very powerful because this actually allows for the logging of individual notebook cell execution. So you can actually, on that sort of really fine granular level, can you create your audit logs and trails for the actual notebook cell execution. I should also caveat that, as you can imagine, if this is for every single cell, those logs are going to get very big. So, you know, be prepared if you're using that feature. Also, from a Databricks SQL side, we have the ability to monitor the SQL query history. So we're able to create a full audit trail of everything that's being executed in the Databricks SQL platform, all of those queries and all of those data sets. So in this example here that I've got in this slide, you've got some select statements of some flight delays databases that I've got. And here, just in this example, we can see the query duration. You can see how the optimization exercise is being done in order to create the most efficient way that Spark executes its jobs, its stage, and its tasks. We can see how long that took. And we can also see the rows that are red and the size of those data sets as well. So you get lots of features there from that. Yeah, so lots of the features from the SQL command, and also there is, as you can imagine, with a lot of these features, there is an extensive API as well if you want to then incorporate that into some further processes. So that is available too. So just to recap, I think I've gone through some of those aspects quite quickly. But yeah, so we've talked about some ways in which the platform is secured, the way that the architecture is managed, how the credentials within that we're using, maybe within pipelines, how they can be secured and backed by our key vault. We've got some security aspects then from a data side, how that can be served to further users or further citizen data engineers by applying things like row-level security or some encryption. And we also got some extensive logging capabilities so we can monitor the entirety of the data estate and the catalog. So we've looked at it from that aspect as well. So that's the last really of my slides. If you'd like some more information, I would highly recommend you go to the Databricks Security and Trust Center, which is available at databricks.com/trust. That's got some really extensive information on all of those aspects. As you can imagine, a lot more in depth on all of those considerations that you need with building out your Lakehouse platform. And again, just as a quick reminder, if you'd like to know some of the content that I'm creating, that's available on my blog, headinthecloud.blog, and occasionally I might tweet. So that's Chris Williams 87. So thank you very much. I hope this was useful. I hope this is informative. If you have any questions, then we can discuss that in the next few minutes.
This was awesome, Chris. I definitely learned a lot. So if you have questions, feel free to put those in the chat. I went to go put reminders and I'm like, oh, I need to listen to this. So so yeah, definitely put your questions in the chat. I mean, I definitely had a bunch. One question I thought I had was you're talking about the audit logs and such. And you know, I'm getting into like some of the governance side of things in my personal job. And so one of the thoughts I had is, how long are these audit logs kept for? Like, I know you have to monitor them so you don't go too long, because I'm assuming at a certain point that creates performance issues. Is there a default length of time? Is there other stuff along that you would advise that we look into as part of that, and some of the defaults that are set up in Databricks?
That is, yeah, I believe that is something I can't. I'd have to look it up, I'm afraid, in terms of what a default value. Usually they are, you know, sort of 30 or 60 days. Perhaps, but yes, I believe you can customize that depending on the requirements of the business. Yeah, I mean, as I mentioned with the verbose logging, you know, you might want a lot less days with that because it does get really extensive. for every cell execution.
No, that's great. No, definitely something to look into. But it's great seeing that all the different stuff that's kind of being built in, especially for some of the governance stuff like lineage and stuff. Like, again, those are definitely things that I'm hearing from the other side of things. So it's great to know it's being built in here.
Yeah, it really has. Yeah, it's expanded just quite a lot just in the last like 12 months. So, yeah.
Yeah. So again, if you have questions, feel free to put those in. But this is really informative. I loved seeing how the different breakdowns of the different types of securities that we think about and how to implement those. Definitely taking notes.
Thank you.
Otherwise, I assume everybody is busy getting that session feedback in and subscribing to the YouTube channel to make sure you don't miss out on the recordings of the sessions you did not get to see.
Oh, yeah. No, and let's go find the session eval. Oh, we have a question. Can Unity Catalog be integrated with Purview? That's an excellent question.
Currently, I don't believe so. The way before Unity Catalog before that came out, there was various sort of solutions that I developed with clients about reading those Spark jobs to be able to sort of push custom kind of data sets to Purview. I would recommend looking at that as a possible solution. There's quite an extensive Apache Atlas API that you're able to generate kind of like Delta entities in the Purview catalog. But I don't believe currently that those two are integrated. Perhaps soon they will be. I don't know. We need to speak to Databricks representative about that.
Okay, no, but that's definitely a great question. Trying to integrate all of that stuff together too.
Exactly. Yeah.
All right, and I just posted the link to the evaluations twice in big letterings in the chat. So, or at least it looks like big letterings here.
Yeah, just making sure that we heard you, Deborah.
Yeah, right. Not, we don't want to say these things are important, but we want to say these things are important. No, definitely. Any other questions?
I mean, you have to keep in mind this event is ran out of Germany, and we Germans would like to shout things. So using bigger letters definitely makes sense here.
Yeah, but you have too many vowels in between the consonants here in this link. Shouldn't there be less for it to truly be German? Or is that just
there should be some umlauts in there, but the thing is, then not everybody would be able to actually type the link. So there's always trade-offs. What I'm saying is I'm making up excuses.
Of course, the most important thing about comments, especially for this New Stars of Data event, is that please don't just put all the ones or all the fives. Please use the comments box.
Put in all the threes is what you're saying?
Put in whatever score is acceptable for you, but make sure that you also put in the reasons why you gave that score, particularly for this event. In general, I would always say that. It's all very well saying, oh, it's a really great session or it's a really rubbish session. Tell me as a speaker why, and then I can do better or carry on do better. For this event, which is specifically aimed at new speakers, you're seeing people who haven't got the experience. They want to take your feedback. So be nice to them, be gentle with them, but provide them with the things that you liked about the session. Chris, your slides are outstanding. I love them. Yeah. Unfortunately, your background is a bit dull and boring with just an ordinary thing. Could have used more Lars Ulrich, and you know that I'm joking when I'm saying that. But it's an example of please provide some good feedback, and we can carry on generating great speakers who are going to carry on bringing benefit to the community.
Constructive
feedback. I just made a screenshot of the attendees just to make sure we really get 15 feedback items back from them, because I see 15 attendees right now. So far, I only got 2 feedback items, but maybe my Visual Basic feedback application is a bit slow today, so it may not be on you.
It's Friday. VB is slow on Friday.
VB is never slow. Let's start at that. VB is the very best. I mean, VB, very best.
There you go. We definitely have a comment in the about a great session. Loved it. So thank you for that.
Thanks.
I totally agree. If you have questions, feel free to put them in here. We still have some time to chat and talk about securing our data lakes, data lake house. So.
Yeah, as I obviously mentioned at the start, my background is very much from a sort of data engineering side. So if there's any particular data engineering questions, then I'm happy to do that too.
Yeah, I did find it fascinating because I haven't had a chance to work with Databricks. So knowing that you have the Databricks Sql and just going, oh, I recognize that. So did you find the transition between the different? I mean, just another flavor of SQL we have to learn as part of it.
Yeah, well, it's ANSI SQL.
Okay.
So obviously, it's if you're from the Microsoft T-SQL, you use that heavily, then it's the more conventional. But yeah, that's also something that is a fairly new sort of feature. Really, it's the rather than sort of loads and loads of transformation notebooks all written in Python and Scala. This is their SQL specific sort of serving interface, really. So it allows that people that are from that sort of SQL background more, they can still have full scope and full use of applying these sort of queries and transformations on those same Lakehouse data sets, really.